Okay, there are a variety of things that we haven't talked about with circuits. We've talked about capacitors and resistors, how they add in series or how they add in parallel, but this is kind of just a hodgepodge of other things that come up. The first thing is let's talk about ammeters and voltmeters. So a voltmeter, which of course measures the voltages of things, so symbolically looks like that, and some ammeter. And oh man, is it 2 M's or 1 M? Pretty sure it's 2 M's, but don't get mad at me if it's actually only 1 M. I can't actually tell even looking at it. So let's say it's 2 M's. And then it's an ammeter, okay? This is going to, of course, measure the voltage at a certain point in your circuit, and this is going to measure the current. Okay, so how are we going to use those? So let's take our circuit, and we'll put in a resistor here. Okay, kind of classic circuit. There's a battery, and there's a light bulb. And if I want to measure the voltage that this light bulb is getting to making sure it's actually getting the correct voltage that it's supposed to get, meaning the voltage of the battery, I put a voltmeter up to it. Well, what we know about parallel things is that we can just put the voltmeter in parallel with the resistor. And so if you hook up the two leads there and there, meaning before and after, what you've done is you've put this voltmeter in parallel with this, and since we know that two things in parallel get the same voltage, that your voltmeter will measure a voltage equal to what the resistor is going to get. And it turns out we want the voltmeter to have a super big resistance. Because if this is a super big resistance, this parallel branch will actually have a very similar resistance to this. And if you remember what happens here, how do you add things in parallel, right? So this voltmeter has some sort of internal resistance. So if you think about how that works, that's 1 over R total would equal 1 over your resistor plus 1 over the resistance of your voltmeter. And if you make that super big, then this term pretty much goes to 0. And then 1 over the total resistance equals 1 over the resistance. And so by adding this in parallel, as long as it's got a super big resistance, you don't actually change the resistance of your system by measuring it, and thus not changing what you're actually trying to measure. Okay, so that's how you use a voltmeter. Now, how do you use an ammeter? Well, an ammeter needs to measure current, and you want to measure the current in a resistor. So if you wanted to measure the current in a resistor, what do you have to do? Well, you better put your ammeter in series with a resistor, because we know two things in series have the same current. So your ammeter's current and the current in the resistor are actually the same, and then you'll actually measure what you want to measure. And we want this to have a super low resistance. If this had a high resistance, so let's say this was some resistance R, and this was also a resistance R, well, then you'd be totally messing up by measuring it, right? Without the system in place, you'd have V equals IR. If V equals IR, and you want to measure the I that's going through this, but if this was, let's say, it was internally about the same as that resistance, then the new thing would be I times 2R, and so you'd actually, by putting in this, you'd create some resistance and actually only get half of the current that the original current was. So as long as this is super low, then the new resistance and the original resistance are the same, and so you actually are measuring the current. Okay, this is something we obviously don't want to have happen. We don't want to add an ammeter and change the resistance. Thus, we would change the current based on the same battery. We want to keep this guy the same, and we keep that guy the same by making this ridiculously small. Okay, so that's how you use those things. Again, this measures current, and this measures voltage. Okay. Side note on an ammeter. Okay. Under what conditions would the ammeter measure anything? And again, when is there going to be current? The ammeter is going to measure current, and when is there current? Well, there's only current when, let's say, the voltage at A is not equal to the voltage at B. This is the voltage at some point A, and this is the voltage at some point B. If VA equals VB, no current no electric field here, no potential difference, and the ammeter would read 0. If the voltage at either one of these were higher, then the ammeter would read something, right? If VA was higher than VB, then current would flow this way, and the ammeter would read something. Okay, so you have to understand how to put meters into place. What about shorting out things, right? They use the word, oh, that circuit just got shorted, or that light bulb got shorted. So let's think about what happens here. And let's take a resistor and a resistor. And so the current kind of flows nice and easy around here. So what would happen if you put another wire right here? Okay, what did you do to this light bulb? Well, this light bulb would go out, because now we're going to go up. We're going to lose all our voltage over this because this is connected to this. So all of this is at the ground. We basically grounded that right there. And then this. So this light bulb would go out in this circuit. No current, no brightness. It's essentially just not in the circuit. Again, shorting something out is doing something like that to that light bulb. Nothing's going to want to flow through there. They're already all back to the ground. So what happened to this light bulb? Well, you actually reduce the resistance of the system. Same battery, smaller resistance, bigger current. So you actually would make that light bulb brighter. You can think about what that means. But certainly shorting out things happens. You got to be able to read a diagram to see, what actually happens. One more thing you'd have to be able to do. We need to be able to look at a system and decide whether or not adding a light bulb is going to make it be brighter or not as bright, or if we change the resistance of a light bulb, what's going to happen to that system. So let's say we have 2 here, and we have 1 more there. Okay? This is some resistance R, this is some resistance R, and then what happens when we have this red one? Okay, what happens if we increase that red one? Well, what happens to everything? Well, if we increase this red one, what happens to the total resistance? Well, we increase it, right? Increasing this and this are in series. Increasing this resistance increases the resistance of the whole thing, which decreases the current all of them are getting, which is going to decrease the brightness of all of them. So you're going to have to be able to play around with questions like that. What happens if I make, this resistance smaller? This resistance smaller makes that whole thing smaller, because in parallel you're smaller than the smallest. And so that resistance smaller makes the sum smaller, which again reduces the resistance. And so you gotta have to think about what happens to what can get brighter, what can get not as bright, things of that nature. And the last thing is I wanted to talk about the internal resistance of a battery. So I know theoretically we would say something like this. So let's say this is 12 volts and this is 3 ohms. And so in theory, we would say V equals IR. So 12 volts is going to cause what current under a 3 ohm resistance? And that would cause some 4 amp current to flow. But in reality, the terminal voltage might actually be a little less than what the theoretical voltage is. The terminal voltage is the actual voltage you get here and here. And so pictorially, they might do something like this. There's the resistance of your circuit, and then right before the battery, they throw in another. They would call that the internal resistance. Resistance of the battery, and it might be some little r. And what that is it's just the fact that as you produce this voltage here, you actually do encounter some sort of resistance, and you can think of it as a resistor either right after the battery or right before the battery, in that these two voltages together make up that 12. And so you're actually going to lose a little bit. And so let's say the internal resistance was 1 ohm. This is 3 ohms. Theoretically, this then is still 12 volts. Okay? And so you would then say that 12 equals I times what? Well, now it's a 4 ohm, because you got to overcome the load of the system plus that, and you get 4, and your current then is going to only be 3 amps. Okay, and if your current's only 3 amps, then you really have a 9 volt drop there, and you're going to have a 3 volt drop here. And so your battery terminals are really only producing a 9-volt potential difference for your circuit. And again, it's not really that hard. It doesn't come up that much, but in reality, and again, the internal resistance is usually much, much lower. Like, it's really small relative to your load, but I just use numbers to make them work out well. But the internal resistance, you can just view it as something that's, you know, kind of right before that. I guess the only other thing I would suggest that eventually you take a look at is redrawing the circuits, because sometimes they're kind of crazy. So you have some battery and it splits off, and you have maybe a resistor that goes this way, you have a resistor that goes this way, you have a resistor that goes this way then, and those connect, and then that connection, you got a resistor that goes this way, and maybe this actually comes down, and you got a resistor this way, and all of a sudden you got some crazy system like that. Okay, so let's label these R1, R2, R3, R4, and R5. Again, I'm going to redraw it, and here's how I'm going to draw it in a very linear way. I'm going to draw it, and then I'm going to start my battery, and I'm just going to go down here. Okay, what are all your battery's choices? So your battery produces a current, and current goes like this, and you get to here, and it can go down R4, it could go across R1, or it could go down to R2. Okay, so let's give it those three options. It could go down R4, down R2, down R1. Okay, R4, R2, and R1. Okay, if it goes down to R4, it's down. Okay, so that's all the way to the battery. If it goes down R1, it's got to then go down R3. So R3 and R1 are in series with each other. Okay, and if you go down R1 and R3, or you can go down R2, you end up here. But if you go down either one of these paths, then you have to go down to R5. So then those then branch up with R5, and then you're down to the ground. And so I would suggest taking this blue kind of crazy one and draw it in this way, and then you easily can see that R1 and R3 are in series. That series is in parallel with R2. R5 is in series with that massive combination, right? This guy is in series with that whole combination, and R4 is actually just all by itself. And I think pictorially you can kind of see what's going on here. Like, these have the same current, this voltage is the voltage of the battery, these two voltages added up would equal to that voltage, this voltage plus this voltage plus this voltage equals the battery's voltage, this pulse voltage plus that voltage equals the battery, and you can start to think about how that all works. And again, this is a little more difficult, so I would rewrite the circuit more in some linear fashion where, like, the battery and then you kind of all flow down this way, or you can all flow left to right or something. Again, those would be suggestions, extra kind of things, but redrawing circuits, the internal resistance idea of a battery, what does it mean to short out, or what happens if you basically use a switch here, and that gets rid of that. Increasing and decreasing certain resistors to increase or decrease the brightness of certain other resistors, and then how to use voltmeters and ammeters in a circuit, what they measure, how they get put in, and then you should know that a voltmeter needs a huge resistance and an ammeter needs a really small resistance.